In this video, we are going to look at a word problem, and I see that the first thing we're supposed to do with this word problem is create a linear model. So background information before I even think about doing any math is what is a linear model? And a linear model, one equation for it is the y equals mx plus b. And I know with that y equals mx plus b that m is the slope. And we can also think about slope as rate of change, and b is the starting value. So now I'm going to read my word problem, looking to see if they give me any of these pieces that would help me create that linear model. So I am told I'm working with an IV bag. 2 hours into an IV infusion, the pump shows that the IV is running at 40 milliliters per hour, and there are 920 milliliters remaining. So as I read that, I noticed the 40 milliliters per hour, and in noticing that, that is a rate of change, which we know is slope. Now I want to think about context a little bit more, so I'm picturing in my brain IV bag, and I'm picturing over here there are all of the markings to help me understand how much fluid's in there, and I know it's set up to a pump, so I have these accurate readings from the pump. But what's happening is that the IV is running at 40 mLs per hour, so whatever the fluid level was at the beginning, it dropped by 40 milliliters over the course of an hour. And then it keeps running, so it drops again by 40 milliliters per hour. And it continually does that. So that constant rate of change is what makes this linear. And the thing that I am understanding from the context is that my slope is a negative 40 milliliters per hour. And I'm using that negative because I'm to write a linear model for the milliliters remaining in the bag, and the milliliters in the bag are going down by 40 every hour. Now, what is not told to me is how much was in the bag to start. So what I do know is that I have this ordered pair to work with, and that is that 2 hours into the infusion, there are 920 milliliters remaining in the bag. And I'm going to use that piece of information to solve for B, the starting amount. So in my scenario, the X is the 2 hours, because X is going to be time, because that is the independent variable. And then based on that, the thing that depends on that is the milliliters. So the milliliters are going to be my Y. All right, so let's get into the math. So I currently have Y equals negative 40x plus B. And I have that because we identified that the rate of change is 40 and it is going down, so it's negative. Next, I'm plugging in my values. So I say Y is the volume of 920. And I know that by several ways I'm calculating the volume. And so that's what my formula should equal. And that is the dependent variable. It depends on how long the IV was running. My X is 2. And then I do not know the B value. So I have a little bit of math and algebra to do. The first math that I'm going to do is to multiply. And so I have negative 80 plus B. And then the algebra that I need is to do the opposite to both sides. So I will add 80 to both sides. And that will give me that B is 1,000. And that actually feels pretty logical because I know that 1,000 milliliters is a common size for an IV bag. So in answer to this first question, the linear model for this is Y equals negative 40x plus 1,000. And a model is just another word for an equation that captures what's going on. And so we have this algebraic model specifically a linear model that captures what's going on with the IV bag. Now I am going to take a moment to erase, and then we'll start with our second question. So from our first question, we have y equals negative 40x plus 1,000. And then we are going to move on to our second question, which says, use your model to calculate the amount of fluid remaining in the bag 8 hours into the IV. So 8 hours, we had identified earlier that x represented the time. And so I will plug this 8 into my formula for the x. So I have y equals negative 40 times 8 plus 1,000. And I am literally going to my calculator and I am typing this into my calculator. So I type negative 40 times 8 plus 1,000, and my calculator tells me that in 8 hours, there's only going to be 680 milliliters remaining in that bag. And so I've answered the second question, 680 milliliters. Now I go on to this third question, and it says, use your model to calculate the time since the IV was started, given the nurse noted that 600 milliliters remain in the bag. We had, at the beginning of this problem, mentioned that Y is the volume, and so this 600 milliliters is going to go into my formula for Y. So replacing the Y with 600, and because we're asked for the time, that means that we're going to be solving this for the time. So we have a little bit of algebra to get x by itself. First step of algebra is to move the 1,000 to the other side by doing the opposite. So I will subtract 1,000 from both sides of my equation. And that gives me negative 400 equals negative 40x. Then to get x completely by itself, I want to do the opposite, so it's multiplied, so I will divide by negative 40 on both sides, and that will give me x equals 10. So this observation of 600 milliliters remaining in the bag happened 10 hours into the IV.